Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on December 10th, 2025, just yesterday. It introduces a method called bind and compose that can pull concepts from single images and videos, then recombine them into new videos with much better concept consistency, including a reported plus 54.67% jump in subjective overall quality over a strong baseline. The paper is titled Composing Concepts from Images and Videos via Concept Prompt Binding. And, as we will see later, the implications for visual creativity tools are quite exciting. Also, the authors shared an official BiCo implementation on GitHub. You'll find a Python package with example apps, inference scripts for multi-concept image and video generation, clear setup and requirements, plus end-to-end training pipelines. It walks you through data prep, prompt augmentation, and training your own concept adapters on custom media. So Figure 1 shows what bind and compose actually does for visual creativity. It takes concepts from separate source clips and fuses them into a single coherent video. The top strip presents three inputs: a butterfly clip, a Minecraft-style landscape, and a volcano scene that later combine into one dramatic lava-filled shot. The middle strip displays that composed result, where all three concepts coexist consistently. The third strip shows a beagle dog video and a bartender video as inputs, while the bottom strip illustrates the playful composition where the beagle now mixes a drink like the bartender in the same bar setting. Figure 2 explains how bind and compose actually works under the hood by separating concept learning from concept recombination. The left side illustrates concept binding, where each binder module reads a text prompt and a reference image or video, then stores that visual concept into specific prompt tokens. The right side shows concept composing, where different binders feed their learned tokens into the diffusion transformer so it can generate a new video that merges both concepts coherently. Figure 3 explains how the hierarchical binder steers which prompt tokens capture which parts of an image or video. On the left, the spatial binders adjust text tokens, so each chunk of the sentence aligns with a specific visual concept. In the middle, the video binder adds a separate temporal branch, which models motion patterns across frames. On the right, the diffusion transformer block uses these updated tokens during cross-attention to produce the final composed video. Table 1 makes the core claim concrete. Bind and compose beats all four prior methods on every metric for video composition. The left columns show higher clip text and dyno image scores, which mean the generated videos better match both the prompts and the source visuals. The middle columns list human ratings for concept preservation and prompt fidelity, where bind and compose reaches around 4.7. The motion quality column also favors bind and compose, indicating smoother and more appropriate movement. The shaded overall column summarizes this advantage, with bind and compose achieving the highest perceived quality by a clear margin. Table 2 shows which ingredients of bind and compose actually matter for human perceived quality. The left side toggles the hierarchical binder, the diversify prompt step, the absorbent token, and the temporal disentanglement strategy, plus the triangle rows that remove the two-stage inverted training. Each added checkmark steadily raises concept preservation and motion scores. The final row, with every component active, reaches about 4.4 overall, which clearly beats all partial variants. Alright, the big takeaway is that bind and compose turns single images and videos into reusable concepts that can be recombined in one shot, with much better faithfulness to both the prompt and the source visuals. This opens the door to far more controllable, creative video tools. That is it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.